Greetings, adventurers. You're listening to The Quiet Journeys of Professor Atwood with me, Professor Atwood. I'm glad you're here, and I can't wait to tell you about my latest journey. Don't worry, it's a safe space. I'll handle all the danger for you. I designed these stories to help you relax, chill anxiety, and go to sleep. Maybe they'll even put a smile on your face, even if it's a sleepy smile. So please, settle in, relax, and prepare to quietly drift off with me to parts known, unknown, and even some places in between. Comfortable? Very well. Let's get underway. Good evening, adventurers. I hope you're doing well. I also hope you're all cozy and settled in because tonight I'm going to tell you about the struggle to regain control of the International Space Station from an unexpected infestation of giant tardigrades. As you remember, thanks to Professor Andrews and his incessant snacking, the normally harmless and almost microscopic tardigrades, nicknamed water bears, had become the size of actual bears and had overrun the station looking for more astronaut ice cream. Now, it was common knowledge the ISS was doing tardigrade experiments in space due to their uncanny ability to survive in the harshest of environments, including outer space. What wasn't so much common knowledge is that the ISS had an entire lab dedicated to tardigrades and kangaroos, but that's a whole other story. It turns out Professor Andrews was quite fond of astronaut ice cream and had accidentally spilled some into the tardigrade's petri dish during an experiment. The tardigrades also had another amazing ability, the ability to co-opt DNA from their surroundings, and they somehow had taken the dehydrated ice cream, thinking it was part of their environment, and in a feat of organic alchemy, incorporated it into their own DNA, thus hydrating to enormous size. It was an unpredictable chain of events, that's for sure. We managed to successfully dehydrate one back to normal size, but that left the rest of the station to deal with, and we had to do it before they got into the rest of the stores of astronaut ice cream. If they did, who knows how much larger they would get. It was a race against the clock. Which reminds me of that time I was in a speedboat on the Indian Ocean, trying to make it on time to the wedding of the son of India's Maharaja. Being late would have been a grave insult, and while the Maharaja's modern-day powers are mostly symbolic now, it's not someone you want to keep waiting. I had been delayed by some pirates who mistook me for a wealthy trading magnate, and when I pointed out that most wealthy trading magnates were riding on yachts, not speedboats, they acknowledged their mistake and sent me on my way. I remembered to report them to the authorities later anyway. Now, while I appreciated the courtesy after their error in ascertaining my identity and profession, let's be honest, pirates are still pirates. Best never to leave them running around loose if you can help it. Anyway, I made it to the wedding on time, and it was a classy, elegant affair. Until the Maharaja's pet monkey started throwing cake. At least I think it was cake. But I digress. Anyway, I will tell you all about how we retook the International Space Station back from a horde of irritable giant tardigrades in a moment. But right now, I'd like to mention something about our stories, especially for the new listeners. You Professor Atwood OGs, I think that's what Bradley says, already know the score. Anyway, the stories are designed for you to drift in and out of, and while yes, I do like to tell you a full story every episode, drifting in and out or falling completely asleep is factored into the equation. You can pick things up anywhere, as that's why I do the story recaps at the beginning, and you can go back and listen to previous adventures anytime you wish. So, by all means, enjoy the show any way you want. It's designed that way. No rules and no pressure, adventurers. I'd also like to nudge you to rate the show with a bunch of stars. Reviews are great too. It's always nice to read pleasant things about what we're doing over here. We're a little stuck on ratings and reviews lately, so we'd love to see that number climb a bit. And this is also important. Don't forget to tell your friends directly about the show and post about it wherever you post about things. The more adventurers, the merrier. Now, before I mention the White Cat Adventurers Club, I want to remind you that we've created a Science and Adventure Helper donation link on the homepage. Just go to whitecatentertainment.com and click Donate for a one-time donation. Then you can do it whenever you like for whatever you like. But if you do want more, there's the White Cat Adventurers Club. How about early access sometimes and ad-free listening to all the shows and an exclusive look at my very irregular journal. Science and exploring is expensive, and your support helps make it happen. And for just $5 a month, you can show your support for the show. There are different tiers with different rewards, including an exclusive t-shirt. Please go to patreon.com/whitecatentertainment and enjoy the access your way. All right then. Let's get back to the story. So there we were, in the International Space Station tardigrade lab, with one deluxe dehydrator/rehydrator, a newly shrunken tardigrade back in a petri dish, and a station still full of giant ones trying to get to the astronaut ice cream in order to get even bigger. We needed a much more elegant and manageable solution. We couldn't waylay and shrink the giant tardigrades back one by one. That would take forever, and they'd get into the astronaut ice cream stash long before we had gotten to them all. No, it was time to regroup and reassess. We needed to get back to the Journeyman. Luckily, there were no giant tardigrades on the way back to the docking hatch, as they were all converging on the station's stores. Thankfully, Captain Flynn and station engineer Vladimir had reinforced the storage area at the beginning of the outbreak to protect the station's supplies, thinking correctly that if there was hull damage, the last thing anyone needed was all of the food and water blown out into space. But they didn't expect the giant tardigrades would deliberately be targeting the area searching for dehydrated ice cream. Nevertheless, their reinforcement efforts should buy us a little more time, but not much. The trip back to the Journeyman was uneventful, as the giant tardigrades were focusing their efforts on the food stores on the other side of the station, allowing us to return unharried. When we returned, everyone anxiously asked us how things went, with Bradley giving Dolores a big hug. It was a breach of protocol, but I let it slide. More often than not, high morale in a crisis is far more important than protocol rules. I debriefed the crew and let them know that we were making progress, but there was still plenty more to do to regain the station. Jillian had prepared lunch, and I deliberately had told her to stay away from anything tardigrade themed, and she agreed. Now was not the time for fanciful space lunches. Instead, she served delicious grilled cheese and bacon sandwiches with a fire-roasted tomato soup. It was just what we needed, and we all fueled up for the next phase of the plan. I took flight engineer Kara and station engineer Vladimir aside and brought them to our lab and put the hydrator/dehydrator on a workbench. I explained the situation and what I wanted to do, and Kara and Vladimir understood immediately. But they added that it would take some time. I said time is something we didn't have in abundance, and they understood and got to work straight away. So while Kara and Vladimir were working, there was nothing more for me to do except, wait. I decided to take a much-needed moment for myself to clear my head. As you remember, when on my ship, the Recovery, my favorite thing is to walk the deck. In space, it's spending time on the observation deck. The ISS had one as well, but honestly, I'm partial to the view from my own ship. Flight Commander Barry and Bradley had a few updates and questions for me, so that delayed my private respite for a bit, but after I answered everything from how do I access the xenon gas fuel reserves to how much longer are we going to be in space, I was ready to take that moment for myself. Flight Commander Barry and Bradley departed and returned to their duties. I was alone at last. I took a deep breath and then gazed out of the large bay window at the stars. But that wasn't the only sight now. We were close enough to home that we could see the Earth. And let me tell you, seeing the planet you live on from up in space is an awe-inspiring experience. It reminds you of how vast the universe is and how you're just a small part of it. It also puts all of your problems in perspective. Everything seems smaller and less important when viewing your home planet and the vastness of space. It was quiet, calming, and beautiful. I looked out at our amazing planet and thought about all of its joy and mysteries that it possessed. Sure, there was hardship and strife, but that wasn't really the planet's fault. I took another look at the vastness of space with all its infinite adventures and mysteries, just waiting for us to explore them. Then I turned my gaze back to Earth and tried to make out any man-made structures from up here. Now, normally artificial structures visible from space without magnification include highways, dams, and cities. The Great Wall of China, often cited as the only human-made structure visible from space, is not really visible from low Earth orbit without magnification, and even then can be seen only under perfect conditions. So that one is a bit of an exaggeration. But the Journeyman's Bay window had built-in cameras and magnification inside it. So I activated them with a voice command and was able to see the Great Wall of China. Luckily, I happened to be here at the right time during the right planetary rotation. Now, interestingly, the centimeter-band spaceborne imaging radar of Space Shuttle missions STS-59 and STS-68 was able to detect not only the Great Wall, but also invisible buried segments of it. So, some space imaging can go even further, which is pretty amazing. Now, whether an object is visible depends significantly on the height above sea level from where it is observed. The Kármán line at 62 miles is accepted by the World Air Sports Federation, an international standard-setting and record-keeping body for aeronautics and astronautics, as the boundary between the Earth's atmosphere and outer space. However, astronauts typically orbit the Earth at several hundreds of miles. The ISS, for example, orbits at about 260 miles above the Earth, and the Moon orbits at about 240,000 miles away, and significantly further. Regardless, I was enjoying both the unmagnified and magnified view of our home planet. I closed my eyes for a moment and did a quick meditation as I listened to the hum of the Journeyman and felt the ship's slight vibration as our gravity ring continued to rotate. I felt calm, safe, and peaceful, even all the way up here in space, and even with being docked with a space station infested with giant tardigrades. After a nice, long meditation, my eyes fluttered open just in time to see Kara and Vladimir smiling triumphantly at me, carrying some kind of device cobbled together from the ISS hydrator/dehydrator. Kara proudly gave me a demonstration. It was a portable area dehydrator. While the range was only a few yards ahead of it, it would do the trick with a room full of giant tardigrades. They had already tested it on a room full of grapes, thanks to Jillian, and Kara added that it looked like we'd be having raisins for a while. I thanked them for the quick turnaround and the ingenious designing. Now it was time for us to go to work and retake the International Space Station. I called back the original party. It would be Dolores, our security officer/mercenary, Captain Jack, Aaron, our medic, Professor Andrews, and myself. But this time, we would all have different duties. Dolores and I would approach the tardigrades and dehydrate them while Professor Andrews caught them in their original petri dishes. Captain Jack and Aaron would work on securing the station and ferret out any giant tardigrades who tried to avoid the dehydrating process. We were once again suited up and ready to retake the ISS. We climbed through the hatch and began heading towards the food stores as Captain Jack and Aaron headed towards the station's bridge. Expectedly, the banging became louder the closer we came to the food stores. It didn't take us very long to get there. Dolores insisted on going first, of course, but I insisted on using the area dehydrator. My plan, my risk. Professor Andrews kept back a pace or two with petri dishes at the ready. It looked like we were just in time. There were no less than 12 giant tardigrades, and they were almost through the hatch to the food stores. I powered up the portable area dehydrator and aimed it at the tardigrades. The effect was immediate. Half of them dehydrated instantly, sending Professor Andrews scurrying to catch them. Since once they were normal-sized again, they were almost microscopic. Vladimir had added an enlargement lens to Professor Andrews' suit so he could find them right after dehydration. The other 6 tardigrades tried to scatter, but their bulk made them slow, and, it was a space station. There was nowhere really to scatter to. I was able to dehydrate the rest of them in pairs, and Professor Andrews caught them in the petri dishes. That was the bulk of them, but we continued through the station, finding a few other giant tardigrade stragglers and dehydrating them. It took less than an hour, and at the end, we had retaken the station. We indulged in a few space high fives and regrouped back in the lab. Professor Andrews secured the tardigrades, which was much easier now, and Captain Jack had gotten all the station systems and the bridge back online. The International Space Station was once again open for business. Soon Sally, their medic, and Vladimir returned to meet Professor Andrews and Captain Jack back on the station. While they appreciated our hospitality, they said it was good to be home and to get back to work. And they missed playing pickleball, something the Journeyman does not have, and I have no intention of adding it. Jillian, our space chef, sent them all back over with some extra snacks, which they appreciated. Obviously, there was a lot to do, from repairs to research, and everyone was eager to get started. They also gave the all-clear back to Earth, so the rest of the scientists and astronauts who were evacuated earlier after the giant tardigrade infestation could return to the station. Now, we were all a bit concerned about a recurrence, but after Professor Andrews did some quick preliminary tests, we were all reassured. As it turned out, the DNA catalyst ability acquired by the tardigrades from the astronaut ice cream was temporary, which made me think the tardigrades had some control over harvested DNA, but not complete control. Or it may have to do with the fact that astronaut ice cream obviously does not have its own DNA, and the tardigrades can only permanently acquire DNA from living sources in the environment. It's sort of like borrowing an air mattress from a neighbor. You bring it home, blow it up, but then after a few days you kind of want your old bed back, so you enthusiastically return it to your neighbor and hope no one visits you again for a while. Regardless, it gave Professor Andrews a lot to study, and he was eager to get started. And he promised to follow all snacking and lab protocols from now on. We took a full International Space Station tour, although it was also a bit like a victory lap, honestly, and we saw the whole station, including the hidden labs, which were very interesting. It was good to have it back under human control, and while the repairs would take some time, the structural damage was minimal. We had definitely solved the giant tardigrade problem in time. Professor Andrews was especially grateful and looked forward to welcoming his fellow scientists back to the station so they could continue their important research. Captain Jack promised to enforce the now much stricter lab protocols with monitoring in place, especially when it came to astronaut ice cream and eating in general in the science labs. Vladimir was instructed to install snacking cameras in all the labs, even the secret ones, to monitor them to make sure the eating and drinking rules were being followed. It was good to know that all the ISS science labs would be back up and running soon. As I've said before, the ISS was originally intended to be a laboratory, observatory, and factory, while providing transportation, maintenance, and a low Earth orbit staging base for possible future missions to the Moon, Mars, and asteroids. Well, I mean, not all of those uses envisioned in the initial memorandum of understanding between NASA and Roscosmos have been realized, of course. In the 2010 United States National Space Policy, the ISS was then given additional roles of serving commercial, diplomatic, and educational purposes. But, science labs and research were always the bread and butter of the ISS. I mean, that's what it was made for, really. The ISS provides a platform to conduct scientific research with power, data, cooling, and crew available to support experiments. Small, uncrewed spacecraft can also provide platforms for experiments, especially those involving zero gravity and exposure to space. But space stations offer a long-term environment where studies can be performed potentially for decades, combined with ready access by human researchers. The ISS simplifies individual experiments by allowing groups of experiments to share the same launches and crew time. Research is conducted in a wide variety of fields, including astrobiology, astronomy, physical sciences, materials science, space weather, meteorology, and human research, including space medicine and the life sciences. As I've said before, this covers a lot of bases, and it doesn't even cover the so-called other research in the secret labs, including the dedicated tardigrade lab, which had caused all the commotion earlier. Scientists on Earth have timely access to the data and can suggest experimental modifications to the crew. If follow-up experiments are necessary, the routinely scheduled launches of resupply craft allow for new hardware to be launched with relative ease. Crews fly expeditions of several months' duration, providing approximately 160 person-hours per week of labor with a crew of 6. Now, a considerable amount of crew time is taken up by station maintenance, probably until about 2030, when the ISS is going to be most likely replaced. When that happens, I think you're going to see a lot more automation, and a lot less attention will be needed to regular daily maintenance. This will, of course, free up more time for experiments and research, and everyone looks forward to that, that's for sure. Perhaps the most notable ISS experiment, well, the most notable announced one, is the Alpha Magnetic Spectrometer, or AMS, which is intended to detect dark matter and answer other fundamental questions about our universe. According to NASA, the AMS is as important as the Hubble Space Telescope. Currently docked on the station, it simply could not have been easily accommodated on a free-flying satellite platform because of its power and bandwidth needs. On April 3, 2013, scientists reported that hints of dark matter may have been detected by the AMS. According to the scientists, the first results of the spaceborne alpha magnetic spectrometer confirm an unexplained excess of high-energy positrons and earthbound cosmic rays, so it was an exciting discovery. Now, as we've said many times, the space environment is hostile to life, of course. Hence the expansive study of tardigrades. Unprotected presence in space is characterized by an intense radiation field, consisting primarily of protons and other subatomic charged particles from the solar wind, in addition to cosmic rays, high vacuum, extreme temperatures, and microgravity. Some simple forms of life called extremophiles, as well as small tardigrades, of course, can survive in this environment in an extremely dry state through desiccation. As I've said before, in this state the tardigrade is called a ton. Now, I think some of the ISS scientists definitely had a sense of humor, as I did notice when we were docking there was graffiti on the outside of the ISS reading "tons of fun." Anyway, medical research improves knowledge about the effects of long-term space exposure on the human body, including muscle atrophy, bone loss, and fluid shift. This data will be used to determine whether high-duration human spaceflight and space colonization is feasible. In 2006, data on bone loss and muscular atrophy suggested that there would be significant risk of fractures and movement problems if astronauts landed on a planet after a lengthy interplanetary cruise, such as the 6-month interval required to travel to Mars. Now, of course, that was 2006, and obviously things have changed significantly since then, like NASA's new positronic drive, an agreement with the Martians to terraform Mars, etc., so you can see how far we've come just from 2006. Now, in a report that doesn't nearly get enough attention, in August 2020, scientists reported that bacteria from Earth, particularly Deinococcus radiodurans bacteria, which is highly resistant to environmental hazards, was found to survive for 3 years in outer space, based on studies conducted on the International Space Station. These findings supported the notion of panspermia, the hypothesis that life exists throughout the universe, distributed in various ways, including space dust, meteoroids, asteroids, comets, planetoids, or contaminated spacecraft. So as you probably surmised, tardigrades don't get all the ISS research attention. They aren't the only space survival game in town, but they do seem to be the only organism, other than a few humans, that actually like astronaut ice cream. Remote sensing of the Earth, astronomy, and deep space research on the ISS have dramatically increased during the 2010s after the completion of the U.S. orbital segment in 2011. Throughout the more than 20 years of the ISS program, researchers aboard the ISS and on the ground have examined aerosols, ozone, lighting, and oxides in Earth's atmosphere, as well as the sun, cosmic rays, cosmic dust, antimatter, and dark matter in the universe. Examples of Earth-viewing remote sensing experiments that have flown on the ISS are the Orbiting Carbon Observatory 3, ISS RapidScat, EcoStress, the Global Ecosystem Dynamics Investigation, and the Cloud Aerosol Transport System. ISS-based astronomy telescopes and experiments include SOLAR, the Neutron Star Interior Composition Explorer, the Calorimetric Electron Telescope, the Monitor of All-Sky X-ray Image, or MAXI, and the Alpha Magnetic Spectrometer. Researchers are investigating the effect of the station's near-weightless environment on the evolution, development, growth, and internal processes of plants and animals, obviously. In response to some of the data, NASA wants to investigate microgravity's effects on the growth of three-dimensional, human-like tissues and the unusual protein crystals that can be formed in space. Now that study is in its infancy, but I'm curious to see where it's going. The study of materials science is an important ISS research activity with the objective of reaping economic benefits through the improvement of techniques used on the ground. Other areas of interest include the effect of low gravity on combustion through the study of the efficiency of burning and control of emissions and pollutants. These findings may improve knowledge about energy production and lead to economic and environmental benefits back on Earth. So everything would soon be back to normal on the International Space Station, and it was time for us to finally head home. Professor Andrews and the crew of the ISS thanked us once again for our help and wished us a safe journey home. And I will tell you all about the last leg of our journey back to Earth next time. But before I end this evening's story, I want to talk to you about something. Tonight, I want to talk to you about perspective. Now, I know I've mentioned it before, but the word takes on a new meaning when you're in space far above your home planet. I took that extra time in the observation area to observe the Earth from about 250 miles away. And if that doesn't give you perspective, nothing will. Now, there's a negative connotation with feeling how small you are, and most of the time that's correct. We're not small. We're all giants in our own right, and never let anyone tell you differently. But the point is not how small we are, but how large everything else is. Space is vast, and the Earth is huge, and both are filled with possibilities and adventure. So never forget what's out there, just waiting to be discovered. Never feel small. Just realize how big and exciting everything is, just outside your little spaceship. Go explore. Good night, adventurers.
The Quiet Journeys of Professor Atwood was created, written, and performed by Chris Mancini and produced by White Cat Entertainment. It is a work of fiction. Maybe. Music and sound design by Ron Tansky at rontanskymusic.com. For more info and merchandise, including t-shirts, mugs, and blankets, go to whitecatentertainment.com.